So now in this question, we have been asked to state a total of two laws. The first one being the law of conservation of matter. And to understand this particular law, before stating it, I am going to take you all into the chemistry laboratory to have a small demonstration for exactly the same. Let's begin. Now over here, when we have come into the chemistry laboratory, we are going to have our first salt. Who is that salt? It happens to be calcium chloride. But for my experiment, I require calcium chloride solution, which means I'm going to take calcium chloride, dissolve it in a small quantity of water. Where do you ask? In the test tube, which is given over here, giving me something called as a calcium chloride solution. After that, who is the second reactant I'm going to need for this particular apparatus? Over here, we are going to take sodium sulfate. But here again, I require a sodium sulfate solution. So I take a small amount of sodium sulfate into my conical flask and add a small quantity of distilled water to it. To initiate the formation of a solution, I'll dissolve it thoroughly and I'll be getting a sodium sulfate solution. Now the time has come that I need to initiate my experiment. But before initiating my experiment, I have taken the test tube, hung it into the conical flask, and it becomes my duty to check the total weight of the reactants. When I put this particular apparatus onto the weighing balance, I get a gross total value of 300.23 grams. Now let's start the experiment. To start the experiment, to initiate the experiment, I am going to take my flask and swirl it left and right, left and right, left and right. A precipitation reaction is going to take place. My first product is going to be sodium chloride solution, and the second one is going to be calcium sulfate, which is formed in the case of a precipitate, which means it is insoluble and heavy. It's insoluble, which means it's not going to dissolve in water, and heavy, therefore it is going to settle down, and therefore indicated by the downward arrow. Let's continue. Let's have a reaction for the same. Number one, who do we have? Calcium chloride reacts with sodium sulfate, gives me calcium sulfate in the form of a precipitate and sodium chloride. The perfectly balanced chemical equation is there in front of you. Allow me to read it out. CaCl2 plus Na2SO4 gives me CaSO4 plus 2 of NaCl. So we have reactants to the left and products to the right. Now to finish off the experiment, it becomes my duty to weigh the total sum of the products. After the reaction has taken place, if I weigh the exact same apparatus, once again, I'm going to get the exact same value of 300.23 grams. So what's your observation over here? Your observation is going to be that the total mass of the reactants is exactly equal to the total mass of the products. And that, my dear child, is the law of conservation of mass, is the law of conservation of matter. Let's put this thing in the form of a statement. So, sodium chloride and calcium sulfate are my products. That's something I'm well aware about. 300.23 grams is the total weight of my reactants and the total weight of my products, which verifies the law of conservation of matter. All that is left, let's put it in the form of a statement. Have a look. So over here, in a chemical reaction, the total weight of the reactants is exactly equal to the total weight of the products formed during a chemical reaction, provided the masses have been measured under the same conditions. Thorough, isn't it? Next one, we have the law of constant proportion. Now to explain this particular law, we have a pictorial representation coming onto the screen. I have water, which I have taken from a total of 3 different sources. The first one is ice water, which must have been packed in glaciers. The second one is river water, that is fresh water. And finally, we have sea water, which is a kind of saline water, salty water. Irrespective of wherever I take my water from, the formula for every kind of water from every kind of source is going to be H2O. And when I take the ratio of hydrogen to oxygen, that is the mass of hydrogen to the mass of oxygen, it is exactly going to be 1:8 in each and every case. Why do we say so? Hydrogen has a mass of 1. But we have 2 atoms of hydrogen over here. So the total mass of hydrogen contributed with respect to water is going to be 2. In a similar manner, oxygen has a weight of 16. So the ratio is particularly going to be 2:16, which can be reduced to 1:8. Which means any kind of water derived from any kind of source is always going to have the exact same ratio of the masses of the elements. And that, my dear child, is the law of constant proportion. Let me write it down for you. Let's have a look. It says, and I quote, the proportion by weight of the constituent elements in the various samples of a particular compound is fixed.